Hi everyone. In coming days, my focus will be on fluid mechanics. So I'll make a few videos related to fluid mechanics and I will try to explain the main concept involved in fluid mechanics chapter, which is important for JEE and NEET. Uh, my teaching experience, what I felt, the student could not able to understand these questions related to which concept. If they understand what concept is involved in a particular question, then half of the problem is solved. The remaining thing is the only calculation. So whenever you read a question, try to figure out which concept is involved. Like in fluid mechanics, there are only few concepts which are going to ask again and again. It is involved everywhere. If you understand this particular question or particular concept, then the problem solving will be easier for you. So in fluid mechanics, it starts with the Pascal's law, and there is Archimedes principle, and after that there is a Bernoulli principle. After that there is a surface tension, and after that there is excess pressure inside the soap bubble and droplet, and after that there is a capillary rise. So first let us try to understand one by one. So I want to begin with this Pascal's law, what this Pascal's law say, and we will see few questions related to this also. Okay. So uh, the Pascal's law, the statement is written here. If the pressure in a liquid is changed at a particular point, the change is transmitted to the entire liquid without being diminished in the magnitude. It is about change in the pressure. So let us try to understand more uh, how it works. देखो यहाँ पे हमें एक क्लोज कंटेनर लेना है, क्लोज कंटेनर, and let's say you apply a force and this container is filled with liquid. This container is filled with liquid, and let's say you applied a force. Then what will happen? You are actually exerting extra pressure, and that pressure is force upon area. Okay. Then this law say that the change in pressure is same, not the pressure in the same everywhere. Change in pressure. Let's say here pressure is P1, here pressure is P2, and you applied an external pressure delta P. So here change is also delta P, and here change is also delta P. So what does it mean? The change is same. If you apply an external pressure in a closed container, then change in pressure is same. चेंज इन प्रेशर, प्रेशर इज नॉट सेम, प्रेशर सेम नहीं होगा, चेंज इन प्रेशर सेम होगा क्योंकि प्रेशर डेप्थ पे डिपेंड करता है. एंड परहैप्स all of you know also that this, if suppose this is liquid and if you go below the depth h and P naught is the atmospheric pressure, then the pressure at this point is P naught plus rho gh, rho gh. Here P naught is called atmospheric pressure, atmospheric pressure, atmospheric pressure, and the P is called absolute pressure. Here the P is called absolute pressure, absolute pressure, and the rho gh part, the rho gh part is called gauge pressure. The rho gh part is called gauge pressure, gauge pressure. There is a proof of this that I'll give it later, because my point of view is try to understand the concept and quickly we have to apply it, because my focus is how to solve the problem, because so many videos are available here and there, and even in the book these are described there. So proof I will give it later. So we will try to see a question based upon this. So let us try to understand that one concept related to this Pascal's law. So hydraulic lift is one of the application of Pascal's law. It is based on Pascal's law. How does it work? Let us try to understand. So it has uh, this pipe like uh, two cylindrical shape tube is there. Okay, and in one the area of cross section is A1, the other area of cross section is A2. So here a force is applied, and when the force is applied here, then liquid try to push this piston. There are two movable piston here. The one piston has a smaller area and the other piston has larger area. So here suppose F1 is applied, the change in pressure delta P1, the delta P1 will be equal to F1 upon A1, and when the pressure is applied here, then the same pressure, the delta P2 appear here, and that will be F2 upon A2. So what is happening? The change in pressure will be same. Just I mentioned in the statement of Pascal's law. So change in pressure will be same. So delta P1 is equal to delta P2. Hence F1 upon A1 is equal to F2 upon A2. The value of F2 is A2 upon A1 into F1. Right. Let's say suppose you have area of A2 area of cross section A2 is 100 cm square. Then the value of A1 you can take 2 cm square suppose. Then the value of F2 is going to be 100 upon 2 into F1. That is F2 will be equal to 50 into F1. So suppose F1 applied force F1 is suppose a 5 Newton. Then your F2 will become 5 this 50 into 5, that is 250 Newton. So it acts as a force multiplier. Okay. So what is the advantage in this? If you apply less force and you can get able to large force. So this principle is utilized in lifting heavy objects like car or something, right? This is known as hydraulic lift. Okay. And in this situation, but energy conservation also you have to think. So let's say you have uh, uh, presses this piston by x1, then this will not rise by the same amount. Instead of this, it will rise by x2 because the volume of liquid will remains same, or the work done at this end is equal to the work done at that end. Force will change, but the energy conservation you also have to think. So how much is the displacement this side? So to understand the displacement this side, if you presses this side by distance x1, then this side a1 into x1 is equal to this side a2 into x2. So the x2 is equal to a1 x1 upon a2. So naturally that side x2 will be smaller than x1. Okay, so you have to think here also the displacement is not same at both sides. Now let us one example based on the Pascal's law. What this question is asking is that here there is a liquid, there are two cylindrical container and they are connected like this. The liquid can flow from this side to this side, and a person is standing this side, and here the area of cross section is given 900 cm square. 900 cm square you can convert into meter square, so you have to multiply 10 raised to power minus 4, then it will convert into meter square. So that is a into 9 into 10 raised to power minus 2 meter square. Okay, a person is standing there and they're asking the difference in the height of the liquid. They're asking the difference in the height of the liquid. So how to solve this? So the pressure at this point, the pressure at this point and the pressure at this point should be same. That Pascal's other statement also say that in the same liquid must be same. At the same level, the pressure should be same. So here the pressure at this point, the P1 is the pressure due to the atmosphere P naught and plus this liquid. So the P1 you can write as P naught and plus rho G H. P naught plus rho. Here P naught is the atmospheric pressure. And here this pressure P2, the P2 pressure at this point. The pressure at this point is atmospheric pressure because it is open to atmosphere. So atmosphere will also put pressure over it, as well as the pressure due to the weight of the person. Pressure due to the weight of the person will be weight of the person upon area. So here the P naught and plus weight of the person will be mg, that is 45 into 10 upon area is 9 into 10 to power minus 2. So this 5, so this is going to be P naught and plus 5 into 10 to power 3 Pascal. So now we can equate both the things, like here P1 equal to P2. So P naught plus rho gh is equal to the P naught plus 5 into 10 to power 3. So this 2 will cancel out. Okay. So the rho gh is coming equal to how much? That is 5 into 10 to power 3. So here the value of rho is how much? 10 to power 3. Z is 10 and the h equal to 5 into 10 to power 3. Okay. So in this, the value of h is how much? The value of h is going to be 5 by 10. That is 1 by 2 meter. Okay. So this is one question based upon pressure. Now one more concept is there, hydrostatic paradox. In hydrostatic paradox, let's say there are 3 containers, and in all 3 containers same liquid is filled with, and here the height is h1. In this also the height of the liquid in all the 3 containers is same, that is h, and the density of the liquid is also same, rho. Okay. Then where the pressure is more at the bottom, here pressure is P1, here pressure is P2, here the pressure is P3. So where the pressure is more? Some students sometimes say the pressure is more here, sometimes they say pressure is more here, and but the thing is the pressure is same everywhere. The pressure is same in all the 3 situations, because the pressure of the liquid does not depend upon the shape of the container. The pressure of the liquid depends upon the height, because you know the pressure, absolute pressure is given as P naught plus rho gh. So atmosphere, it is open to the atmosphere, so atmospheric pressure is same in all the situation, as the container is open to the atmosphere, so atmospheric pressure is same for all the situation, and the rho, density of the liquid, is same for all, and g is also same for all, and h is same for all, so the pressure will be same in all the situation. So pressure at the bottom of the container does not depend upon the shape of the container. It depends only on the height of the liquid. Once more I am repeating. This phenomena is called hydrostatic paradox. What does it say? It says that the pressure does not depend upon the shape of container. It depends only on the height of the liquid. Okay. Just before discussing this question, I want to explain the relative density. The relative density. What is the relative density? Relative density, the relative density RD. The relative density is defined as density of substance, density of substance by density of water, density of water. Okay, so let's say the density of mercury. The density of mercury is 13.6 into 10 to the power 3 kg per meter cube. Then the density of water, you also know that it is 10 to the power 3 kg per meter cube. So the relative density RD, this RD is RD, relative density of mercury is how much then? The relative density of mercury, the density of mercury will be here 13.6. Mercury is 13.6 times denser than water. You can understand in a simple way. Suppose you have 1 liter of water bottle. Generally, you use for your this school. This suppose you have 1 liter of water bottle, right? And let's say you're filling it with water. Then it will contain 1 kg of water, right? 1 kg of water. But same thing if you fill with mercury, then it is going to contain 13.6 kg of mercury. Okay. And let's say suppose you're going to fill it completely with gold, then it is going to contain 19.3 kg of gold. So even gold is more denser than mercury. Gold is more denser than mercury, right? So that is the meaning of relative density. So generally sometimes in the question they will not give you the density, they will give you the relative density. In that case, actual density is relative density into 10 to the power 3, means density of the water. Okay, let's try to understand this question. In this question, how to solve this U2 problem? In U2 problem is really common in fluid mechanics. Like they will give you a U2 shape glass tube, and one limb they will put another liquid, another limb they will put another liquid, and they will give the density of one, and sometimes they will ask you the density of the other one. In this question, what they are telling, that in the liquid shown in the figure, two arms are mercury and water. If the difference of the height of the mercury column is 2 centimeter, find the height of the water column. In this, they are asking the height of this water column, right? So I just mentioned at one level of liquid, at one level of same liquid, the pressure is same. So here, this is our level, right? Here, let us try to understand. यहाँ पे इसके ऊपर हमारा क्या है? वाटर है, इसके ऊपर हमारा क्या है? मर्क्यूरी है, राइट? Okay, and below this there is mercury, and below this also there is a mercury. So now two conditions we have to check. One, the liquid must be same, and the level should be same, then only the pressure should be same. So our both the condition is satisfied here. The one, the liquid is same, that is mercury at this side, and mercury is also this side, and the level is same. Okay, so now here the P1, this side the pressure is P1, right? And here the pressure is P2. So P1 will be equal to P2. As it is open to the atmosphere, so that actual pressure will be P naught plus rho GH, So rho means water this side, and Z is 10 you can take, or H we don't know. This side, it is also open to the atmosphere, so you can take P naught and plus P naught plus rho, this side mercury, so mercury is 13.6 into 10 to the power 3, the density, and the G10, and H is 2 centimeter. 2 centimeter it can convert into meter by multiplying 10 to the power minus 2. Everything you have to take in SI unit of system. This P naught going to cancel out. This 10 to the power 4 H is equal to 13.6 into 10 to the power how much? This is 10 to the power 3, and 10 to the power 4, 10 to the power minus plus 2 10 to the power plus 2, 10 to the power plus 2 into 2. So this is 10 to the power 4 into h equal to uh, 13.6 into 2 into 10 to the power 2. So the value of h is this 2 and 27.2 into 10 to the power 2 upon 10 to the power 4. So by solving this, it is going to come 0.272 meter, or you can say 27.2 centimeter. Okay. So this is question based on pressure.